In this lesson, we are going to learn some basic query statements in MySQL. We'll learn how to retrieve database data by using the select statement and how to use the select statement clauses such as from, distinct, where, order by, and limit. Then we'll introduce how to use a join keyword to combine data from different tables, and how to query multiple tables with a join keyword. 3 types of joins will be covered: cross join, inner join, and outer join. We'll learn how to use outer join and inner join to identify matching and mismatching rows. After that, we'll focus on some troubleshooting problems. You will be able to find and solve problems by using warning and error messages. And finally, we'll come to a description of SQL modes and learn how to use SQL modes to change the interpretation of SQL syntax. In MySQL, select is the most commonly used DML statement. The select statement describes the data to be retrieved from the database. It does not specify exactly how to retrieve the data. The database server returns a table that contains only the rows that meet the select criteria. You can use select to evaluate expressions too. You can add the expression to the column list. For example, we enter select 2 plus 2, it will return 4. The example in the slide shows a typical multiple-column select statement. It retrieves the name and continent column values from all the rows in the country table. You can select one, multiple, or all columns from one or more tables. You can use asterisk to include all columns without listing them individually. For example, we enter select asterisk from country. It will include all the columns in the country table. You can use these optional select clauses alone or in combination to generate specific query results. There are 5 types of clauses: distinct, from, where, order by, and limit. Distinct clause is used to select unique rows. It will eliminate duplicate rows from the result set. From clause is used to select rows from a named table. That means you can specify which table to query. You can define some conditions in where clause. Only rows that meet these conditions can be returned. Order by is used to return the results in a specific order. A limit will limit the number of rows to be retrieved to a given number. It limits the maximum number of rows in the result set. And finally, you must pay attention to the order and syntax of the optional clauses. If you do not use them in the correct order, you will get a syntax error. Here is an example of the difference between select without and select with distinct clause. You can see in the first column, we enter select continent from country without a distinct clause. And then we get 239 rows returned. In the second column, we enter select distinct continent from country. Then we get only 7 rows returned, because all the duplicate rows have been eliminated. If there are null values in the table, it will treat all nulls as the same value. The example in the slide compared select with and without distinct when there are null values in the table. In the first column, we select I and j from T without distinct clause. The second and third rows both returned null values. Although they are identical, they also displayed in the result set. And in the second column, we add distinct to the query. So we get only one null value returned, because all the null values are treated as the same. So the distinct clause eliminates the duplicate ones. You can use many types of operators in a var clause. For example, arithmetic operators, comparison operators, logical operators, and some other additional operators. First, let's see arithmetic operators. Arithmetic operators perform mathematical operations in column value expressions, such as addition, subtraction, multiplication, division, integer division, and modulo. The comparison operators are used to compare column value expressions. The comparison operators include less than or equal to, and another equal to. This equal to works even for null values. Not equal to, greater than or equal to, greater than, and between. Here, between indicates a range of values which is between value 1 and value 2. Logical operators combine Boolean expressions. There are 4 logical operators such as AND, OR, exclusive OR, and NOT. There are also some additional options in the where condition. For example, in is equivalent to a list of comparisons with OR, but it is more readable and efficient. Is null is used to check whether a value is null. The syntax is where column name is null. And you can use the like operator for pattern matching. For example, where value like pattern. Parentheses is used to group parts of an expression. My SQL evaluates the part in parentheses first, and use that value to evaluate the rest of the expression. If more than one part of an expression is in parentheses, the evaluation order is from left to right. My SQL evaluates the innermost expression first, if parentheses are nested. Operators can be applied to almost all types of value expressions, such as literals, columns, function calls, and so on. You can also combine several criteria with logical operators. Now let's see an example of where within. The example in the slide demonstrates how to use the in expression in a where condition. You can find a list of specified city names along with their corresponding ID and district from the city table. We enter select ID, name, district from city, where name in New York, Rochester, Syracuse. And then we get 3 rows returned with the city names of New York, Rochester, and Syracuse. Here is an example of where with and or. The example in the slide uses and with an or expression in a where position. We enter select name, continent from country, where government form equals to republic, and continent equals to North America, or continent equals to Europe. Then we get all countries in North America and Europe whose government is a republic from the country table. Now let's see how to select with order by. By default, the server returns the rows in the select statement to the client in no particular order. The actual order depends on various factors, such as the order MySQL stores the rows in the table, or which indexes are used to process the query. If you want the rows to be returned in a specific order, you can use the order by clause. It will return the output rows in a specific order. The example in the slide sorts the names of the countries in the country table in alphabetical order by name. We enter select name from country order by name. Then we get the rows returned in an alphabetical order, starting with A. And next, we will see a more complex example. This example uses order by in a more complex where query. We select name, continent from country, where government form equals to republic, and continent equals to North America, or continent equals to Europe. Order by name. Then we get the cities that meet these conditions, such as republic from North America and Europe, and those cities are sorted in alphabetical order from A to Z. You can also specify order with SC and DSC. ASC means ascending order. DSC means descending order. Order by sorts values in ascending order by default. You can specify the sort order explicitly using the ASC and DSC keywords after the column names. For example, we enter select name from country order by name DSC. The statement will sort the names of the countries in the country table in descending alphabetical order, that is from Z to A. Pay attention. Order by also works with functions, mathematical operations, and any value expressions. You can also sort multiple columns simultaneously. For example, we select name, continent from country, order by continent descending, name ascending. The example in the slide sorts the continents in the country table in descending alphabetical order, and sorts the country names in ascending order for each continent. The continent column is an enum. Therefore, The order of its values depends on their placement in the list, which just happens to be alphabetic in this instance. Now let's see how to use select with limit. The limit clause constrains the number of rows that appear in the result set. You can use limit clause with either one or two arguments. For example, you can use limit with row count, and can also use limit with skip count and row count. You must represent each argument as an integer constant. You cannot use expressions, user variables, and so on. When followed by a single integer row count, limit returns the first row count rows from the beginning of the result set. As shown in the example in the slide, if we want to select just the first 8 rows of the name column from the country table, we can use limit 8. You can also specify how many rows to skip before starting result set. When followed by two integers, skip count and row count, limit skips the first skip count rows from the beginning of the result set and returns the number of rows specified by row count. As shown in the example in the slide, to select the next 8 rows that come after the first 20 rows of the name and population columns, you can use limit 28. Then you will skip the first 20 rows and select the next 8 rows. You can use limit in conjunction with the order by clause. This is used to put the specified number of rows in a specific order. MySQL applies order by first and then limit. One common use for this is to find the row containing the smallest or largest value in a particular column. For example, we select the name from country, order by name, limit 8. This combines the previous limit example with order by. It returns the first 8 rows of the name column in alphabetical order. Here are some tips on how to use select. First, you must treat table and database names as case sensitive. Second, from the MySQL command line client, you can use \c to abort a SQL statement. You can use \g at the end of a statement to see results with each column in a row instead of as a table. This is useful when the output is too wide for the screen. At last, you should pay attention to the use of asterisk. To select asterisk means to select all the columns in the table. This can be a waste of resources like time, disk space, and so on. And it may result in potential maintenance problems. For example, if you add a column to a table, select asterisk queries on the table will automatically retrieve values for the new column. This might not be what you want. The select queries shown so far in this course retrieve data from a single table. You cannot answer all questions in this way. Some queries need data from multiple tables. You can use a join operation to combine data from different tables. A join creates a temporary result set that contains combined data. To join tables, there must be a relationship between certain columns in these tables. If you want to find the details of records referenced in a foreign key, you combine data from two or more tables with a table join. The table in the slide shows three types of joins: cross-join, inner join, and outer join. Cross-join combines other rows from one table with other rows from another. Inner join identifies combinations of matching rows from two tables. Outer join identifies combinations of matching and mismatching rows from two tables. Most joins are qualified and are used to combine related tables. The join condition expresses a meaningful relationship between the data sets. For example, a city is a capital of a country, and a country has cities. So there is a meaningful relationship between city table and country table. When you cross-join two tables, you combine each row from one table with each row from the other. This produces all possible combinations of rows and is known as the Cartesian product. Joining tables this way can produce a very large number of rows, because the row count is the product of the number of rows in each table. A cross-join between two tables, each containing 1,000 rows, returns 1,000 multiplies 1,000 equals 1,000,000 rows. That is a lot of rows, even though the individual tables are very small. This type of join is also called an unqualified join. You can join two or more tables by listing them in the from clause of the select statement, and separate multiple table names by commas. Use the where clause to indicate the relationship between the tables. Imagine that you want to list all the languages spoken in every African country by using the World InnoDB database. You cannot get this information from just one table. You have to retrieve the country names from the country table and the languages from the country language table. The join creates a new virtual table, which exists only for the duration of the statement. This table contains the code and country name from the country table and the corresponding language from the country language table. You can use the inner join keyword instead of listing join tables in the from clause. You can also specify how rows are matched between the tables in the from clause, not in the where clause. On and using clause conditions instruct MySQL how to perform the join. Recall that the purpose of the previous example was to join the city and country tables on matching city names. The first example in the slide uses inner join and from on to get the same result. If the name of the joined column is the same in both tables, you can use using instead of on, as per the second example in the slide, and list the names of the joined columns within its parentheses. For example, in the join queries in the slide, you match the two tables by columns with the same name. Therefore, you can rewrite this statement with using. You should note that on and using are not functionally identical. Using treats the columns from the two tables as the same. On treats them as two different columns. The join keyword is equivalent to the inner join keyword, and you can use either to achieve the same result. The query in the example counts the cities in South America. The city table does not contain continent data. This information is in the country table. so you need to join the city and country tables. The expressions following the on clause must be a condition. In this example, the on clause states that a city row matches a country row only when the country code column value in the city table equals the value of the code column in the country table. You can filter the result set further with the where clause. In this example, the join applies only when the continent is South America. Use the on clause for conditions that specify how to join tables, and use the where clause to restrict which rows you want in the result set. Outer joins identify combinations of matching and mismatching rows from two tables. There are two types of outer join, left join and right join. Left join returns all rows from the left table, even if there are no matches in the right table. Right join returns all rows from the right table, even if there are no matches in the left table. They answer the same kinds of questions, but differ slightly in syntax. For example, an inner join can match country names in the country table with the language spoken in those countries. You can do this through a join with the country language table based on country code. But this cannot tell you which countries do not have an associated language in the country language table. To answer this question, you need to identify which country codes in the country table are not present in the country language table. An outer join gives you this information. We can use left join with the where clause to find mismatches in two or more tables. With the left join, the comparison that takes place between the joined tables is based on the first or leftmost table referenced in the select statement. If you are interested in only mismatches, you can use an appropriate where clause to check which rows in the left table do not have a matching row in the right table. For example, we select name, language from country. Left join country language on code equals country code, where country code is null. In this example, countries with no entry in the country language table have a null value for country code, so we get those mismatching rows using the where clause. Now let's see how to use right join and where clause to find mismatches. In a right join, the rows of the tables are reversed. A right join produces a result for each row in the right table, irrespective of whether it has any matches in the left table. The previous example demonstrated a left join between the country and country language tables. This example uses a right join to join the same two tables. Because all rows in the country language table have matching rows in the country table, there is no null value returned, so the query produces an empty result set. Using is an easier way to reference columns that have the same name in both tables. You can use it instead of on when column names are the same in both tables. For example, we enter A left join B using C1, C2, C3. When tables A and B both contain columns C1, C2, and C3, this join operation will compare the corresponding columns from each table. Null is used to identify rows with no counterpart in the other table. If there are no matches, the join condition returns null. If there's no matching rows for the right table in the on or using part of a left join, the right table returns a row with all columns set to null. The example in the slide lists all rows in Table 1 with an ID value that is not present in Table 2. That is all rows in Table 1 with no corresponding rows in Table 2. Table references can be aliased. You can use alias instead of the table name. The syntax is Table 1 name as alias name or Table 1 name alias name. Here, the as keyword is optional. For example, we select t1.name, t2.countrycode from country T1, city T2, where t1.name equals t2.name. This example joins the country and city tables on city names. The country table is given an alias of T1, and the city table is given an alias of T2. Typically, alias is an abbreviation of table names, rather than giving the meaningless name. The query in this example returns a list of country names and codes. Many MySQL statements generate warnings and errors. There are three components of these messages. In MySQL error code, a SQL state error code, and a text message. A MySQL error code is a numeric error code which is MySQL specific. It is not portable to other database systems. A SQL state error code is a 5-character SQL state value. The values are taken from Unsigned SQL and ODBC and are more standardized. Not all MySQL error numbers have corresponding SQL state values. In these cases, the general error code is used, that is HY triple zeros. A text message is a message string that describes the error. For error checking, use error codes, not error messages, because error messages might be changed. If the database administrators change the language setting, that will affect the language of error messages. In the example of the slide, the error message indicates that there is a syntax error in your statement and recommends that you check the menu. The information string for multiple row statements is a summary rather than a complete listing of diagnostics. Warnings and errors are not always displayed by default. You can use the following statement to turn on error and warning output, show warning, and show errors. Show warning shows information about any errors, warnings, and notes that resulted from the lost statement in the current session. It shows nothing if the lost statement used a table and did not generate any messages. That means a statement uses a table but generates no messages. Show errors only shows the error messages. The list of messages is reset by each new statement that uses a table. You can also find out what an error code means by using the para utility, which displays a description for a given error code. For example, we enter para options error code. We will get a description of this error code. You can also use the MySQL reference menu to look up the meanings of error codes and get help for common problems. After you understand the error or warning, you can make any needed changes and run the SQL statement again. The MySQL server can operate in different SQL modes and can apply these modes differently for different clients, depending on the value of the SQL mode system variables. You can set the global SQL mode to match site server operating requirements, and each application can set its own session SQL mode to meet its own requirements. SQL mode settings can make it easier to use MySQL in different environments and in conjunction with other database servers. SQL modes may govern behaviors like which SQL syntax MySQL supports and what data validation checks it performs. To set the SQL mode at server startup, you can use the SQL mode equals mode value option on the command line, or you can set it in an option file. Here, mode values is a list of different modes separated by commas. To clear the SQL mode explicitly, you can set it to an empty string. To change the SQL mode at runtime, you can set the global or session SQL mode system variable using a set statement. For example, set session or global SQL mode equals mode value. Setting a variable with the global options requires the super privilege and affects all clients that connect from that time on. Setting the session variable affects only the current client. Any client can change its own session SQL mode value at any time. You can use select statement to view current global or session SQL mode value. Now let's see some common SQL modes. The first one is unsigned SQL mode. It will change syntax and behavior in MySQL to conform more closely to standard SQL. The second one is the strict mode. Strict mode controls how MySQL handles invalid or missing values in data change statements, such as insert or update. For statements such as select that do not change data, invalid values generate a warning in strict mode, not an error. Strict SQL mode includes two options: strict trace tables and strict all tables. Strict trace tables enables strict mode for transactional storage engines such as InnoDB, the default, and when possible for non-transactional storage engines such as MySQL. Strict all tables enables strict mode for all storage engines. Invalid data values are rejected. Strict SQL mode is in effect if either strict trace tables or strict all tables is enabled. For transactional tables, an error occurs for invalid or missing values in the data change statement when either strict all tables or strict trans tables is enabled. The statement is aborted or rolled back. For non-transactional tables, the behavior is the same for either mode if the bad value occurs in the first row to be inserted or updated. The statement is aborted and the table remains unchanged. If the statement inserts or modifies multiple rows and the bad value occurs in the second or latter rows, the result depends on which strict mode is enabled. For strict all tables, MySQL will return an error and ignores the rest of the rows. However, because the earlier rows have been inserted or updated, the result is a partial update. To avoid this, please use single-row statements, which can be aborted without changing the table. For strict trans tables, MySQL converts an invalid value to the closest valid value for the column and inserts the adjusted value. If a value is missing, MySQL inserts the implicit default value for the column data type. In either case, MySQL generates a warning rather than an error and continues processing the statement. The third one is traditional mode. It makes MySQL behave like a traditional SQL database system. It shows errors instead of warnings if you try to insert an incorrect value into a column. Now let's make a summary of this lesson. In this lesson, we first learned how to retrieve database data by using the select statement. Then we learned how to use the select statement clauses such as from, distinct, where, order by, and limit. We introduced the usage of each clause and how to use them. And then we learned how to use warning and error messages to troubleshoot problems. Next, we give a description of SQL mode and introduced how to use it to change the interpretation of SQL syntax. Thank you for watching. See you next time.